Thank you everyone for coming. Really appreciate it. My name is Matt Weidner. I am a student here at CC. So here's just a quick introduction about me. So I've been studying JavaScript and full stack engineering here, but previously I was in the game industry for about 2 years. And before that, I was teaching English and working in pharmaceuticals prior to that. So I'm really excited to be here to talk about something I personally like a lot, which is inverse kinematics, and hopefully explain it at a higher level and kind of let you guys understand a bit more about what it is and why it's important and why we should think about it. Just more about me, I love the outdoors, I love soccer, and I love climbing. I also love games, so I hope we can share that interest today. So I want to start the talk off with just a have you ever question. And that question is, have you ever just kind of looked around at the world and appreciated it? You know, just kind of looked at the beauty around you and thought about the complexity of it and also the simplicity of it, and thought about maybe what that means to you as a person, and not just as a person, but as a human, and the way that we experience this world around us. I think this question is really important, especially when thinking about something like creating a new world. So game development involves the creation of new worlds. And there are just 3 little points here I kind of want to talk about you all with. So when we create a world, I think we all naturally inject a bit of ourselves into it. A bit of our own perceptions of reality, a bit of how we imagine things, a bit of how we view the world. And as we do that, I think it's important to remember that it's possible to share that perception. These aren't completely subjective. We can have objective ways of sharing our perceptions of the world, and mathematics is a way of doing this, right? More specifically, physics. So understanding physics and having that command of objective reasoning can really help to create these objectively believable situations that we can share with one another. So it's like, oh wait, I need math, yeah, about that kind of thing. I personally have not studied math seriously or intensively at any point in my life, but I've studied game development, and therefore I need math for that. So let's just do a quick dive into some things that might be useful for this talk. So mechanics, and more specifically, the mechanics we know in physics. So what are mechanics? You know, a branch of physical science that deals with energy forces and their effect on bodies. So by bodies, I'm talking about objects. And in a game world, you might think about models or characters or the things in your environment that you want to manipulate, right? And there are a couple of ways for us to do this. So has anyone heard of these vectors or scalars? Anyone familiar with these concepts? Yeah? Okay? Yeah? Okay. It's a quick definition of a scalar. So this would be a quantity that's fully described by a magnitude. So a numerical value alone, right? A number. Just a couple of examples of that. You might have kilometers per hour. If you're from where I'm from, that would be miles per hour. And time can also be considered a scalar value, believe it or not. A vector, on the other hand, would be that value along with a direction. So we can take kilometers per hour and tack on a direction to that, and suddenly we have a vector. So kilometers per hour east, 50 kilometers per hour east would therefore be a vector. And there are a number of things, you know, that build off of these concepts, like distance or displacement, perhaps velocity, acceleration, speed, all a combination of scalar quantities and vector quantities. And so then this kind of brings me to kinematics. And kinematics is the science of describing the motion of an object using a word or a diagram, perhaps numbers, graphs, or equations. And this is, you know, something that we all do every day, regardless of our understanding of physics or math or the sciences. That we have words we can do this easily with, such as stopped or slowing down, speeding up, turning. We have a vocabulary for this naturally. But obviously the aim here is to use kinematics as a branch of mechanics to develop a more sophisticated way of doing this, a more complex way of describing the world around us. Yeah, the goal is to describe the motion of real-world objects. So with that said, I kind of want to do a little bit of an experiment. And you're all free to join in, or you can just watch me. I'll be doing it up here. And this experiment is really simple. So if you're holding something, you can put it down in front of you and kind of let your arms fall down to your side. Yeah, just like that. And then right in front of your face, within arm's reach, if you can imagine a ball just floating in front of you. And clear your head. And I want you to very simply reach out and grab that ball. Just like this. And then maybe return your hand down to your side. Just like that. Nice. Now, did anybody think about any of the concepts I just described while you were doing this? Anyone? Were you thinking about vectors or scalars, distance, displacement, any of those things? I think the answer is probably no. And the reason for that being that that motion is unconscious. It's human. It's natural for us. We don't need to think about these higher concepts when we move in the world. But the problem is, when we try to map movement in a virtual world, we need to think of ways of translating this human unconscious movement into something very real and relatable in a virtual environment. But how do we do that without really intrinsically understanding what is going on in our own heads when we do something as simple as grab a ball? And people have devised a couple of ways of creating this motion, kind of simulating this motion in a believable way. Two of these concepts, kind of where the talk is going to go from now on, discussing these two concepts, more specifically the latter concept, inverse kinematics, but forward kinematics and inverse kinematics, and how they can help us to map motion. So I think we might be familiar with this picture if you know Elon Musk and the work he's done. But he has a factory with Tesla where he builds cars, and he has robots that do this for him, right? And in each one of those robots might look something like this. So on this simple robotic arm, we have a couple of joints. Okay. We have a shoulder joint, we have an elbow joint, and we have a wrist joint. And so the goal here is to kind of coordinate motion of these joints to allow this drill at the end to reach some end point where it can do its job, right? Where it can drill something. And if we were to approach that with a forward kinematics approach, we might do this kind of in this way. We might say, okay, let's move the shoulder. Let's focus on moving that shoulder. And in doing so, we'll move the hand closer to where it needs to be. And from there, we can make further adjustments with the elbow. We can adjust the elbow's height, we can lower the hand from the elbow. And finally, we might adjust the hand, and that might be a rotation, it might be a simple tweak. And the goal of that being, here's a little model I made in Maya to kind of like elaborate this point. The goal of that being that we achieve a motion. And that motion leads us to some place. So I'll play that one more time. You can see that we have a shoulder, an elbow, and a wrist joint here. So the first motion is from the shoulder. The second motion is from the elbow. The third motion is also from the shoulder. And then the final motion is going to be from the wrist. So this would be like a forward kinematic approach of moving a chain of nodes like this. So then what's inverse kinematics? Well, inverse kinematics is the opposite of that. So we would approach it in an inverse way. We would go from the hand, and then we would go to the elbow, and finally to the shoulder. So from this, it might be a bit difficult to imagine what I'm talking about here. But if you imagine a parent-child relationship here from the shoulder to the elbow to the hand, then any motion that occurs at the hand will influence the elbow. Any emotion that occurs from the hand and elbow will therefore influence the shoulder. And when you have a motion like this, the only real thing you need to be concerned with is the end position of the hand. The other nodes will position themselves accordingly. And I have a small GIF here that kind of illustrates that point. So you can see that the hand is being manipulated, and from that manipulation, the rest of the body is following suit and adjusting its position. Okay. But I mean, well, robotics, obviously, like IK is used in robotics. I'm more familiar with kind of animation side of things, so I kind of want to talk about that. In games, you'll find 3D animation, quite obviously, CGI. You'll also find motion capture technology being used. and a combination of those technologies as well. And obviously you'll find sprite animation, 2D animation being utilized in games. But IK probably is not going to be as important here. So if I'm going to talk about IK, I feel like I have to talk about this man, Alexander. He was the technical art director at a company called Ubisoft. I don't know if we're all familiar with that company, but he did some pretty amazing work with IK and combining IK with human motion capture rigs to create variable and very complex, yet at the same time simplistic skeletons for models in games. An example of that would be this octopus. He created this with human motion capture data and laid over an octopus model and was able to achieve animations without using FK. He used IK to create animations for that octopus. I have like a small video here from a talk he gave some time ago. I can just pull up the right scene. Here we go. So on the left side, just pause it real quick. Ooh. Okay. So on the left side here, you'll see an FK rig. This blue man is an FK rig. On the right side, the yellow man is going to be an IK rig. And you'll notice the terrain is varied, right? This is randomly generated terrain. And so the goal here is to have these models respond accordingly to what they're encountering in this world, right? From an FK approach, as I talked about, animating down the chain, you'll have to account for, you'll have to kind of think about anything that your model might encounter, right? And animate accordingly for that. An IK approach is responsive. So if I play this clip, you'll kind of see that responsiveness occurring. Once again, FK on the left and IK on the right. Sorry about that. There we go. Okay, so yeah, you can see he's being quite responsive there with his terrain. And again, there's another area of this that I think is quite interesting. Around this area here. Yeah, this really drives the point home, doesn't it? Yeah, none of these animations are pre-configured. This is all IK running in real time. Yeah, powerful stuff, truly. So you might think of reasons why we might consider IK in animation. So, I mean, you take a standard game and you have items that you're giving your characters. So you think, okay, in development, I want 50 items in this game, and I want each player character to be able to hold this item. So then the animator's job then is to say, create 20 animations for each item, and then for each character. So the more items you have, the more work, the more time, the more cost. And those things rise and rise and rise and rise, right? And so then naturally you have a cap of how much work you can do. Whereas if you're using an IK approach, suddenly your character model is responsive. Suddenly it is not limiting you as a developer, as a designer, what you want to achieve. So if you want to say, add in a bazooka, then go on ahead and add in that bazooka because your model is going to respond to it realistically and accordingly when you need it to. And you know, this is obviously depending on the rules that you create for your IK rig. But at the end of the day, you can get these really interesting, responsive kind of scenarios that are believable and require very little work on the part of the developer. So yeah, with suddenly we're looking at the world differently now because the real world is full of scale, it's full of size, it's full of difference. And we often fail to achieve that when creating games. We attempt to mimic it, but it's a very hard thing to replicate. For example, I don't know if you know World of Warcraft, but you might have characters of varying heights, varying sizes, varying scale. And suddenly you have to match the running animation of all of them to the same speed. And what happens then is you have shorter characters running with inhuman strides to match the speed of the taller characters. And of course, you can tweak that. Perhaps on the side of the animator, you might be able to tweak that to make it more believable. But I mean, an IK solution would allow your character, your model, to adapt to changes in scale in believable ways. So some kind of downsides might be that it's quite hard to program. You know, a common technique would be the Jacobian inverse technique. I'm not familiar deeply with this technique, as it is incredibly complex. And you know, as a result of that complexity, it can be really rough on your hardware. So if you're trying to, you know, spread your game out into the market in a way that it's accessible to people with maybe lower spec hardware, that might be a challenge that you're going to encounter, especially if you're doing console development. But you know, it also might not fit with the style of the game that you're trying to create. So there's a lot of games out there that have these really unique stylistic attributes to them. And that is what keeps people coming back. Minecraft, you know, Pokemon, another. There's parts of Pokemon that we all love that they try deeply to maintain with each iteration, right? Sprite animation for fighting games. You know, these are all kind of things that we expect out of a certain genre. Mario as well. And Hearthstone or card games, you know, maybe 2D sprite animation on a 3D environment. Or Candy Crush. You know, none of these things require IK. You don't need it. But there might be times when IK is... Get this in. There might be times when you need IK to reach that level of realism, that level of believability that you want in the world that you've created. You know, because the goal here is to create a human experience. And IK can help make your world more visceral. You can help people to connect more deeply with the ideas you're trying to present them. You can drive immersion. I can see, you know, already IK being applied with VR in this way. For example, tracking the hands and having the arms move accordingly based on hand movements. That you can do this with motion capture as well, but IK is a much easier solution. And people are deriving simpler IK solutions like right now, every day. People are very motivated about this technology and trying hard to find ways to make it usable, applicable, to spread awareness. And if you're familiar with Unity, you know, you can use the asset store to find C# scripts there that people have written for IK. Maya has some inbuilt IK options. So yeah, I explored Maya a bit for IK, and I thought I would demonstrate some of what I created there for you guys today. Okay, so here's the arm that I made. I showed you in the slide earlier. It's a simple 3-jointed arm. And we're going to kind of do an FK approach to animating it right now. So I'm going to start at the parent, the elbow, right? And we're going to do a simple rotation on it. As I bring it up, you'll see the whole arm follows, right? I can do whatever I want with the arm. It's going to follow that parent mode and the motion that it makes. And if, you know, once I achieve a position there that I like, I might move down to the second or the first child and do a movement here. Right? So now we've got kind of an arm cocked gesture. And finally, I can kind of adjust the hand into a desired position. And then as an animator, I might say, all right, great, and snap a keyframe right at this moment. And then I'll kind of, you know, adjust it a bit more, and snap another keyframe. That might be an approach toward FK animation that I could take as an animator. Conversely to that, IK animation, I think you'll see is quite different. So if I take my IK right here, looks the same. I still have joints. I still have a shoulder, an elbow, and a wrist. The only difference is that I put an IK handle on here. And you'll see now that the range of motion comes from the lowest child in the chain, the hand. So any change I enact on this child here is going to perpetuate up through the chain to the shoulder. And I can do some pretty crazy stuff here really easily, really simply. So, I can just reach it all the way back here and get that full range of motion at the shoulder just from manipulating that hand, I can go as crazy as I want with that. Get some punching motion there. Yeah, so really interesting stuff. And as a conclusion to that, things like VR and AR are coming. I think VR has been around for a while, but AR is coming up in a big way, as Julian is discussing across the room. But when you're developing AR, I think the biggest struggle that you're going to come across with is finding ways to kind of immerse yourself, not just in reality, but in what you've decided to overlay, right? Because that juxtaposition of what you've created and inserted and what you are used to observing all the time in reality can be very jarring. And it can be very hard to create something that is easy and believable, like in an AR setting. So we need to think of solutions for that. This is a time when I feel like coming up for a solution, it's a very exciting time for AR. And IK, I can see applications, but I don't want to just make this talk about touting how great IK is. I think that the idea is we need to be thinking of ways to make believable solutions in AR for this human-like experience that we want to translate into a virtual world, whether that be IK or something else. And I personally have been working on a game for the last week in C#, and this is just like a snapshot of it, but I would love to use IK in my game in conjunction with VR to create some fun experiences, and I think any developer can get excited about this technology. So thank you. I really appreciate everyone listening. I hope that was an enlightening topic. There's a lot of great talks going on today, so feel free to check them out, and if you want to talk to me afterwards, I'm open.
Hello everyone. Today, thank you for coming today to listen to my project. And today I'm going to talk about Android app and Kotlin and Android Studio. And I want to talk about how to create Android apps. So about the process. And have you ever had the experience to create own Android application? Okay, yes, very nice. So this is for beginner session. So I can tell you something. And hello again, I'm Takashi, and I'm from Tokyo, and I'm a team manager, a system developer company in Japan, and my dream is to create our own computer graphics and games. And I'm also beginner about Kotlin, Android application, and Android Studio. And I'm good at infrastructure and never give up mine, and Vue, React, Redux. I hope so because I learn these front-end things in Code Chrysalis rapidly, very rapidly. So I'm interested in React Native, 360, and React Kotlin. So yeah, let's focus on Kotlin and Android apps. And today's agenda, first, mobile industry, and next, coding tools, and demo, and development processes. So my presentation goal is so all of you understand entire development process. So first, smartphone users So 2009, iPhone 3G released. It's not many people, but in 2011, actually I bought my smartphone this time. And 2013, Android share wins iOS share. And it's increasing year by year. And 2019, so active world smartphone, 5.9 billion. And so at that time, world population, 7.7 billion. So huge number. And so I have experience to go to Masai Mara National Park in Africa. So I met many Maasai people. Some of them have the smartphone. I'm surprised because they live in a village surrounded savannah. So I mean, many people have. Okay, and about Japan, about 75% people have a smartphone. So one more thing, so there are two types Android application, and so one is a business support Android application, Android game application, and I want to focus on the game, and because personal developer can create own game, so. How about game industry? So total 13 trillion yen and increase 20% in a year. And Asia is the biggest market. So do you know esports? So nowadays esports became well known, and next the Sports Asian Cup Commissioner Rwanda, esports joined the sports competition in 2022 China. And so next about mobile game industry. So 50% of the game industry, 6.9 trillion yen. It's a mobile, and Asia occupies 60%. So there are possibility if you create a nice Android application in Asia, it may be able to be your side business. And so, for example, there are Tetris, Puyo Puyo, Sudoku, Nemesis, Gradius. That kind of Android application is easy to create, I think. But it's popular. So yeah, there is a chance. And so I introduced coding tools. And first one, Kotlin. What's Kotlin? So Kotlin is Google's preferred language for Android app and compatible with Java. And it's announced in Google 2009 in conference. And Kotlin and Java can invoke each other. And so strong point, support both backend and frontend. So Java is only server-side, backend. And eliminates null pointer exception. So null pointer exception is famous error in Java. So Kotlin has a strict check for null. And concise coding style like JavaScript. So for example, Kotlin syntax. So when we create data object in Kotlin, use data class, generate setter, getter, and many convenience things automatically, only this code. But so in Java, we write so many things, but it's definitely same meaning. So Kotlin is a very concise style. And Kotlin's data class has convenient features like destructuring. It's like JavaScript, and copy is not reference copy, I mean. And so when we code something, so we need some convenient tool. It's called Integrate Development Environment, so IDE. Android Studio is Google's official IDE for Android app based on IntelliJ. So IntelliJ is a famous Java developing tool, and so do you notice something from IntelliJ's logo color? So it's very similar color to Kotlin. So why is it similar? Because same company. So JetBrains produce IntelliJ and Java, IntelliJ and Kotlin. So they create IntelliJ. It means they know about Java and they know about wrong point of Java. So they decide to create own language. So it's Kotlin. And futures supports Kotlin and Java, of course. And boilerplate project, I will talk about it later. And Android virtual device is an emulator on your machine. So it's very look like real mobile phone on your machine. And building systems with hot reloading for AVD. So today's demo is Oslo game, so reverse game. So I know this is minor game in other countries. So first I'll explain rule. So Oslo rules gets the 8x8 checkerboard and 64 black and white disks. Okay, and place 2 black and 2 white disks at the center of the board for start position. And battle start. And place the disk in a spot that surrounds an opponent's disk, and flips out flank disk to its opposite side. It can be a row of one or more disks in horizontal, vertical, or diagonal line. So this is an example for a horizontal way. And so pass the turn until there is no spot left. So who wins? So finally, we count the number of disks. And this time, white 22, black 42. It means black win. So let's start demo. So this is a Android Studio. It looks like IntelliJ, and this is a AVD, Android virtual device, and I build and select target. Target is that AVD, Okay, now building. I hope it's coming. Yes, yeah. So this is my Othello game, and first white turn. So this is horizontal way, and this is diagonal way, and this is vertical way. So it works, and so it's also come to my smartphone, and so I make on app. So and I put here, and so when we can play like this, so it's work. It's nice. So it's not difficult. So return to my presentation. Okay. So from now I can explain the development process. So first, let's create your new project. And Android Studio automatically generate default template like this. So for example, this is for testing, and this is for constant, and this is for building. So but for beginner don't understand all of things. So I recommend only 3 things. So manifest XML, Kotlin source, and layout XML. So manifest XML is activity definition. So one activity means one screen, one page, and so Kotlin logic and layout XML. So basically, one activity has one logic and one layout. And code and debug. So if you get an error after coding, you can debug your code. So use print line if necessary. So it's same as console log, JavaScript. And Android Studio's debugger. And I recommend Android Studio's debugger. And it's general debugger with another. It's same with another IDE. And put the breakpoint and push the debug button. That's easy. And so for debugging, there are 3 basic things: step over, execute whatever happens on the next line, and jumps to the next line. And step into, if the next line contains a function code, step into will jump to and post that function at its first line. And step out, execute the remainder of the current function, and then process at the next statement after the function call. And Android debugger also shows the exact value line by line. Okay. And about visualization, so layout XML like HTML with strict positioned elements. And for example, Kotlin can get ID cell22. So by find view by ID cell22. So we can get the element, and we can customize something about that element. And in my case, all spots are button in my Othello, because each button use event listener easily. So, but it's in my case. So, what you visualize is up to you. So, build and deploy. So build is easy, use Android Studio. So just click the button. So all things are set up. And get the APK. APK means Android Application Package. And for deployment, there is two choices. To use free tools or Google Play. So free tools are available for only test deployment. And to deploy and publish to Google Play, a registration fee of $25 is required. And if you are a Google Play developer, Google Play is available for test deployment. Okay. Today I'm gonna talking about test deployment using DeployGate. Is free tool because we like free. Now I'm student, you know. And so first login, DeployGate website, and upload APK to DeployGate. It will generate QR code and scan the QR code with your mobile. And install DeployGate, and that your application will be installed. So, for example, building. So you just push this button. So after that, building process, and we can get APK file. It's easy, very easy. So, and this is a DeployGate page, my page, and at the bottom there is a button, and push the button and choose your APK file. So, and next page, so your application's QR code comes. So scan this one, and you can get the Android application in your mobile. If you want to share your Android application, push this button, and so shows the download link and send it to your friend. And now you know the entire process. So, and in conclusion, so Android Studio provides me a lot of convenient features, more than I thought. And the board games are good for learning for programming as a beginner, like chess and checkers. Have understand rules, one-page application, and recursive logics. So recursive logics is complicated, sometimes overkill me, but so if you made it, it makes you fulfilled, satisfied. So, and Kotlin can organize front end and back end. So if you run Kotlin, so you can make application front end and back end. So thank you for listening. Yeah, that's all.
Hello everyone, thank you for coming. My name is Matthew Cook, and just a little bit about me. So I'm originally from Florida, and I previously used to work in the medical field. I specialized in orthopedic and cardiothoracic surgery, but I kind of always felt the pull towards IT. And after some convincing from some developer friends in Tokyo, they kind of brought me under their wing, helped me a lot with mentoring and self-studying, and learning kind of about the world of IT, which eventually led me here in front of you guys today. And so my passion to kind of build new things and always continue improving my coding skills is what brought me here to code Chrysalis. And so today I'll be presenting kind of about what is React Native and is it truly better than native development. So this is more just an overview of what you can expect as someone who is possibly a beginner coming from like a web development background or just in general curious about it. So let's take a look. So what is React Native? So React Native is a framework based off of the React library. And because of that, it's going to follow along with React conventions. It's a framework that allows you to build cross-platform applications for both iOS and Android. And these applications that are built are actually native. They aren't just a web view that is labeled as a mobile app. And of course, this is all done using JavaScript and JSX. So what does this all mean and what do we all need to get started? So let's take a look. In order to begin using React Native, straight out of the box, there's going to be a few prerequisites. First, of course, being JavaScript, as the whole premise of React Native is the ability to write native applications in JavaScript. Secondly, you should also be familiar with the command line and have a basic understanding of either NPM or Yarn. So to understand how all of this comes into play, let's take a look at the required developer environment. So if you're more familiar with native mobile development and you would like to include some projects using native code, then it requires a proper setup for this environment to get everything running smoothly. So for both environments, there are going to be some requirements, whether you're using iOS or Android. So first is going to be Node, which is our JavaScript runtime environment, and Watchman, which is a tool that was created by Facebook for watching changes in the file system, and the React Native CLI or command line interface. From there, each platform is going to have its own specific requirements. So iOS requires setup of Xcode and its dependencies, including the Xcode CLI. And Android is going to require its own setup, along with numerous dependencies and configurations. If you've already worked previously with either of these and they are already installed and configured on your machine, then it's great. You can be up and running in just a couple minutes. If you haven't worked with these before, then you can expect to spend at least a minimum of an hour kind of testing your patience as you go through the installation and the configuration process. If you're like me though, you just kind of want to jump in, get excited to build something, just want to go. So React Native also has you covered. So this is the Expo client. It's a set of tools and services that are kind of set up for quickly building and deploying your mobile app. So it's included in the official React Native documentation and is a great way to get started. To do that, you need to begin by installing Expo CLI with the following command. So you would install this on the global level. Then you would run expo init and the name of your project. Finally, you will change into the directory of your new project and simply run expo start. Then your development server is up and running and we now have a successful bare bones React Native app. So let's kind of take a look at what that looks like. So, again, I've already installed the Expo CLI, so all you need to do is type expo init. I'll say my awesome project and run this. And it's going to bring up kind of a workflow for you to choose. Do you want to start off with a blank canvas or do you want something already pre-configured? So just for the sake of the demo, we'll go with pre-configured. And we'll just kind of set up, welcome to our project. And we'll use Yarn to manage our dependencies, why not? So it's going to install all of that. So while it does that and gets it all set up, we will go into our actual project file. And from there, you just run expo start. and it's going to bring you to this interface. So now you have your development server up and running. Then from there, you run it on your iOS simulator, and it's going to launch inside your simulator. All right, and here we have it up and running. So what exactly is React Native app, and how is this all beneficial? Well, React Native and the library it's based off of promotes reusable components. So when starting to develop an application, you need to break everything down into small pieces. It's what's often called the single responsibility principle. So the ultimate idea behind that is to break your app into the smallest pieces possible, keeping reusability in mind. Usually for a React Native project though, you can reuse roughly around 80 to 90% of your code, even in future projects. And this is kind of what makes it so beneficial. And so what exactly are these pieces I'm talking about? So using JSX, which looks similar to HTML syntax, we can create some React Native components. So this is not an exhaustive list, this is just a few examples. But first we have Vue, which is our container for anything in your application. For web devs out there, it's kind of similar to a div. Next we have text, which you could equate to a span tag. Third is the image, which of course is used for displaying images. And then we have our button component. So let's take a look at some of these components in our newly created project. So this is kind of the home screen that was built for us directly from using Expo and Knit. And everything you can see here, these are our platform independent components that we imported in. And of course we have our Vue, like I mentioned, which is the container for everything, an image, and of course our text as well, like I mentioned. So, the important thing to take away from this is that components can and will be reused in your application, and many of these are platform independent. So what this means is that they will behave the same whether they are used on iOS or Android. So React Native supplies a wide range of components, and you can use these to build some amazing experiences, but there are some components that are platform dependent. So this means that the way they look, the way they interact, and are implemented is different between the platforms. And here I've listed just a few. So let's see a couple examples of these. So here we have headers. The headers are highlighted in red, and as you can see, they are rendered differently on each platform. So on the Android, you can see that the header is kind of flush up against the toolbar at the top, whereas on iOS, you have kind of this white gap up here at the top. So that's one thing you got to keep in mind while developing, is kind of how it's going to look like, what it's going to play out, and you're going to have to style each of these differently. Next we have lists, which they are rendered generally the same on Android versus iOS. But one thing that you can notice in particular is our segmented control, which on Android does not render because this is not an Android specific component. So, and that is here just the ability to switch between these two lists here. So the dependent components that I've shown here, there's many more listed, and they are what defines kind of the differences between the two platforms. So the question is, how do we handle these? Well, React Native supplies us two ways of detecting what platform your app is running on. So the first is to import the module from React Native. And you have platform.os, which will return whether you're working in an iOS or an Android environment, and platform.version, which returns your Android version. And this is only for Android itself. The second is to conditionally import your components based upon their environment. So you would use platform.select. For iOS, you will require your components that are iOS components, and Android, you're going to, of course, require your Android components. So this is really helpful for when there are edge cases where you need to use platform-dependent components. And so let's kind of recap here. So I introduced independent components, dependent components, and platform detection. So independent components, again, are important because they are the most used and reused components throughout a React Native application. However, some independent components will have additional functionality on some platforms. So that is one thing to look out for as you are developing. Dependent components are where you bring in kind of the difference between the platforms. And thankfully, React Native kind of presents two ways of dealing with this platform detection. So now it's only a matter of learning the components, how they work on each platform, and which ones to use depending on the platform. So this all sounds easy, right? We'll never have to worry about errors or anything of that nature. But just in case, let's kind of go over how we might deal with that scenario in React Native. So debugging is a very important part of the development process, and when working with mobile development, this can sometimes be tricky. So let's take a look at some of the options we have. So when using Expo, you are presented with an in-app dev menu, and if you're using a Mac, pressing Command D while your simulator is running will bring up this menu. So for just the demonstration purposes of this presentation, I'm going to stick specifically with Expo and the iOS simulator. And this has nothing to do with the tons amount of time required to set up the Android Studio environment. So anyways, there are many different options here, but let's go over a couple that are important to React Native. So first is reloading the JavaScript bundle. So this option is similar to, in a way, refreshing the web page. The bundle is recompiled and run again. And you aren't required to bring up the in-app dev menu for this one. You can simply just press Command R in the iOS simulator or RR twice if you're using an Android simulator. And I'll show that now. So here we have our menu and just reloads, and as you can see, it recompiled and reloaded the app. So next we have is one of the great features of React Native is hot reloading. So what this means is that instead of fully reloading the JavaScript bundle, as I previously mentioned, the React Native packager is aware of what code that you changed, and it will replace only those pieces of code. So this is a huge time saver, especially in complex apps, because there can be many screens and a lot of navigation required to return to the screen where changes were made. And this is also in addition to waiting for everything to recompile and reload. And next we have the performance monitor. So the performance monitor provides kind of the basic monitoring of what your application is using within the platform environment. So this includes things such as the UI frame rate, the JavaScript frame rate, and the number of views rendered. So using this monitor can help to point out performance or code issues in your app and kind of provide an insight of where to begin the debugging process. So for example, the JavaScript frame rate kind of refers to the business logic that is being run on the JavaScript thread. And that is where your React application lives and API calls are made. Also some of your touch event processes, a lot of the work done in your React Native application. So one reason this is important to look at is that doing heavy logic in React Native can impact the way the frame rates are loaded. And this in turn will lead to kind of a perceived user delay in response, or also even animations. And we can take a look at that. So we have our performance monitor, which is kind of small here, but for example, it's just showing we're using about 197 megabytes of RAM just for this basic application, and showing the UI is rendering at 60 frames per second, and JavaScript is rendering the same. If you are to change, you'll see that JavaScript drops down as everything is processed and then loads back up. All right, so next we have the element inspector. So those of you that are familiar with web development will kind of recognize this as using like the Chrome dev tools to inspect the layout of your HTML and its hierarchy. So this is a great feature that is available in React Native. And let's kind of take a look at what that looks like. So if we pull up the element inspector, you can click on something there, and it's going to list your hierarchy of where everything is contained within. And if you can get it to scroll down, there we go. It also shows you your box model, your paddings, your margins. It'll show any kind of CSS that has been applied, and also it'll show you what line of code this is actually within your React Native project. And if you have your, say for example, Visual Studio open here, you can click this line and usually it'll take you directly there. So next we have live reloading, and this is kind of a feature that all web developers should probably be familiar with. So every time you make a change to your code base and save it, this is going to automatically reload your application for you. And one thing that you may have noticed when I was pulling up the in-app dev menu is that live reloading and hot reloading cannot be enabled at the same time. And the reason for this is they would basically just cancel each other out. So as you can see here, if we pull that up, turn it off. So once you enable, say, hot reloading, you'll notice that live reload is blocked off. And in order to switch back to live reload, of course, you'd have to disable hot reloading and enable your live reloading. So this finally brings us to remote debugging, which is one of the most important tools offered by React Native. So using this, you can debug using Chrome DevTools. And this operates in the same fashion as debugging during web development. But in the interest of time, I'm not going to display too much of that. That could be an entire lecture in itself. But this is one thing that is really important to mention, especially because it not only gives you the ability to use Chrome DevTools, but also you can use the React DevTools plugin to kind of gain more access and more features. So now for every developer's favorite thing, errors. So errors in React Native are shown just like in this image here. They're a nice full screen display with a lot of data, and they show kind of a lot of the important details that we would need to figure out the problem. So the nice thing is that not only do we get a good idea of what the problem is and where it is, but we also get a suggestion or suggestions kind of depending on the problem and on how to fix it. So in this example here, you'll see that I've got a syntax error, and this is useful to recognize kind of what problem you're having. And it's happening on line 35 of homescreen.js. And it's pointing out that the error seems to be a missing JSX closing tag for the text label. And of course, if you look on line 35, you can see that, oh, I just simply forgot a T in my closing tag. Oops. Now, the red errors are enough to stop your program from running, and they do require immediate attention before continuing. But there are also warning errors as well. So these errors may not necessarily cause your app to crash, but they do contain important information that should be kind of checked and resolved. So the warnings will display as a pop-up at the bottom, but you can also click on these and it will display full screen like I have shown here in the image. You can also trigger these warnings yourself by using console.warn. And just like the previous red screen errors, these also provide kind of suggestions as to how to resolve the error. And you can disable these during development, but it's usually not recommended. One important thing to note, however, is that the red and yellow error messages are automatically disabled in your production builds. So there's no need to worry about going in and configuring, turning these off, turning them back on. It's something that's taken care of automatically. So we've talked about kind of the different pieces required to build out our application, and as well as how to handle any errors that come our way. So we've also gone over some of the benefits and potential drawbacks to working with React Native so far. And with that under our belt, let's kind of talk about how we can make an awesome app even more awesome. So of course with CSS, which is kind of a true love-hate relationship with me. But only with React Native, we don't use really a special language or syntax for defining styles. It's just good old-fashioned JavaScript. And all of the core components except a property named style and its names and values usually match how CSS works, but there are a few exceptions. So the names are all written with camel casing, which if you've used React at all before is something you should be familiar with. And the style property can be a plain old JavaScript object. It can also be an array of styles, where the last style in the array has precedence. So as a component grows bigger and more complex, it is really common to use stylesheet.create to define out all of your styles in one place. So here I've got just a simple example that was taken directly from the documentation. And one thing you may have noticed here is that there is no mention of pixels, ems, rems, or any other kind of measurement for the font size. And the reason being is that's not something you do in React Native. If you were to actually declare pixels, it would come out as an invalid syntax. And some of the properties that you would expect either do not exist or are kind of renamed in their own unique way in React Native. So now that we've kind of understand what React Native is and how it has its own approach to styling, this can be a bit frustrating to sort through, especially when you're encountering numerous style errors. So one example is background image, which you would expect to just be background image, but a lot of times when you type this out, you're going to get a syntax error. Reason being, it is actually image background. So that is one thing to look out for. One nice thing of React Native, though, is working with dimensions. You can simply just import dimensions, and React Native allows you to kind of work with them as you please. There's no need, you don't need to kind of calculate them yourself. Also, using JavaScript objects and style sheets makes it a bit easier to apply the styles conditionally. And you can kind of apply these styles based upon the properties in your components. So bringing this all together, kind of how does React Native work? Well, in React Native, there are 3 layers, and that is the JavaScript layer, the bridge, and the native layer. And the JavaScript layer is, it's an event loop. And this is where the bridge kind of passes information to the native JavaScript layer, and this is where all of your application logic comes into play. So it is processed here, and then React Native will handle the outcome accordingly, such as triggering kind of the UI to re-render when a button is pressed. Then you have, of course, the bridge layer, which kind of connects the JavaScript and the native layer and passes information between the two. And the native layer is what collects the data and events, such as registering a touch request or a network request, sends it to the bridge, which then, of course, passes it on to the JavaScript layer. It also processes the commands that are received and updates the UI as needed. So I know what you're thinking. This has been a lot to take in, and this is a very robust framework, and I've only been kind of skimming the surface. But now that we have kind of a solid understanding of what React Native is and some of what it presents, let's kind of dive into why we should consider it or not. So I'm going to talk kind of about mobile development in general. So iOS and Android are the two most popular platforms currently, and each of these require a different programming language. So iOS requires Objective-C or Swift, Android is Java or Kotlin, and what this means is that even if you're making the same app, it effectively needs to be written twice, and this could require separate development teams. So how does React Native approach this? So it provides a single JavaScript code base that is for your two different platforms. And this means it's easier to maintain by having the same development process for both iOS or Android, along with allowing you to reuse a majority of your code. It's also potentially would require less developers, as one developer, for example, could work on both platforms at the same time. So the previous slide may kind of make it sound like a solid win for React Native, but the benefits that I've just listed also come with a cost. So iOS and Android have different design guidelines, and they have a big share of UI differences. So if a project requires adhering to kind of these specific guidelines, then you're going to need to write native code anyways. And this kind of just negates the purpose of having a single code base and a single team. So when would you need platform-specific code? For native modules, these are modules which handle specific features, such as the ones I've listed here. Your camera, some push notifications, and third-party services such as Auth0. And React Native does have React Native Link, which is a way for handling these native modules. But sometimes additional steps are required, and this almost requires going through a heavy installation process and a lot of documentation. And if you're unsuccessful, this just leads you right back to needing platform-specific code. So all in all, this brings us to the conclusion. Is React Native worth it? Is it better than native development? So the answer is, of course, it depends on your project. And React Native is great in many cases. It's good for beginners who are just looking to jump into the world of mobile development. Anyone transitioning with a web development background will find the transition pretty smoothly. You can build things out quickly and easily. But the nice thing is you're not stuck with JavaScript. You can expand further into using native modules and even open up the code base you've already written in Xcode or Android Studio to further build out, for example. All right, so that brings us to the end of the conversation, or the end of the presentation. Thank you very much for your time. If there's any questions, you can ask me later or contact me at the information provided. Thank you.
Thank you everyone who took their time to come to my tech talk. I'm very excited to talk to you about 2D, 3D animations made easy with AnimeJS and ThreeJS. So before we dive in, just a little bit about myself. My name is Rina Sakamaki. I'm from Japan. And previously, I worked in a cybersecurity company as a system engineer. I used Java to rebuild backend systems, but later on, I developed an interest in building beautiful design and UI. So I decided to become a full stack engineer. That's why I'm here. And yeah, like I said, I am a full stack engineer, but I'm leaning slightly towards more of the front end side. So yeah, this is why I picked my topic. But before we dive into the hows and the nitty-gritty details, let's talk about why we should talk about animation in the first place. Why is it important? So one of the reasons might be because with animations, it gives you a lasting and memorable experience, whatever you're looking at or the experience you're having. Sorry. So yeah, when you think about animation, you might think about Pokemon or Disney or Tom and Jerry, all these cartoons and animations and yeah, films that we used to enjoy as kids growing up. And as kids, I'm sure we all experienced this time in our lives where in school we would forget what we learned 2 or 3 weeks ago during exams and totally fail. But somehow when we grow up, we still remember these experiences we had as kids because animations are truly impactful and they leave a strong impression on our brain. So, but is that all? Like animations, is it only limited to animes or films? Not really. So it leaves a huge impact on businesses as well. To show you this, I looked into a statistic, video marketing statistics to know for 2019. And in this study, I learned that 83% of marketers believe that videos and motion pictures are growing in importance when it comes to selling their product. Because 53% of customers responded and actually engaged with the brand after looking at products on social media, for example. And interestingly enough, the numbers are the same, but a different story. 53%, there has been a 53% increase in ad spending by companies from 2016 to 2019. So just in 3 years, there's been over a double increase in spending towards ads. And this is because companies believe that animations are truly important when it comes to selling their product. But this is what companies believe. But we as humans can also agree that it's not really, it doesn't come as a surprise because we can all agree that we enjoy visuals like this happy sun that you're looking at. It's smiling at us. And there's even studies showing that human brains, they can process information 60,000 times faster than looking at text, for example. So now that's out of the way, we understand how animations are important. And myself as a developer, I wanted to learn how to create animations in a quickly and easy way. So the JavaScript libraries that I'm about to present to you fit this goal. So yeah, this talk, I have one goal, and that is for you all to, by the end of this presentation, to think, oh, this seems easy, I want to try it out. So this goes for everybody in this room. You don't have to be a JavaScript developer or even a developer at all. I believe that what I'm about to show you is really easy for anybody to try out. So in order to fulfill this goal, I would take you through 3 steps for each library. One is I'm going to take you through the demo. I created an app so that you can see what you can do with these JavaScript libraries, and show you some code snippets and show you how simple it is. And lastly, go through my personal opinion, likes and dislikes about the JavaScript library. So yeah, let's jump right into it. 2D first. AnimeJS. So can I see a raise of hands of anybody who has ever heard of AnimeJS before? Yeah, okay. Most of you don't know. So for those of you who don't know about it, there are 3 things that you might want to know about it. So as I mentioned, it is a JavaScript animation library. It is extremely lightweight, and it has a simple yet very powerful API. And it works with many things, one of which CSS, SVGs, DOMs, JavaScript objects. So let's jump right into the demo. I have 3 demos for you today. The first one is this one, which is you see donuts. And it's a very simple animation. I just click anywhere on the web page and it will start animating. So I'm going to click it and it moves to the other side of the page. Why am I showing you this? So it may seem like a very simple animation. So this is what you're looking at is the AnimeJS official website, and it explains to you the 3 main powerful the strengths of this library. One of which is staggering, which I just showed you. Here you can see a much more complex animation going on, which is a red circle moving from point to point, and based on where it is, it creates this wavy effect. So yeah, just to show you how I did the demo, the code for this is just 15 lines. It's very, very simple. Here on line 1 you can see add event listener, which listens for your click action. Wherever you click, it invokes this function from line 3 to line 13. And in AnimeJS, basically when you want to create an animation, you start off with anime, which is very simple. And anime has lots of methods, but 2 main methods that you might want to know about at this point is timeline and add. So timeline is basically, it takes in an argument, and in here you can pass in all the global settings that you want your animations to have. And in the add method, it takes in an object as well, and in here you declare the settings that you want each individual animation to have. So in my case, I only have donuts moving from side to side, so that's just one animation. That's why I only have one add. But if you want to make your animations much more complex, you will just chain a bunch of adds. So it's very easy to read. This is pretty cool. The next demo I have for you is another donut, and you click anywhere and it moves in a square motion this time. So this is yet again a second strength of this JavaScript library. It's layered CSS transformations. Again, it's a very much more complex animation than what I showed you. And it says one element is all you need, and basically what that means is you just need to have a global element selected, and by just that you can manipulate all the elements that is nested inside of it. And in this demo I showed you the keyframes that is being highlighted here. So just to take you through the code I wrote for this one. This one. Oops. Yeah. So again, we have an add event listener. It listens for your click action, and yeah, it just has only one timeline and one add, just like the other one. And the only difference is the keyframes I talked to you about. I'm not going to go into detail, but it's pretty straightforward, I guess. If you look at it, the donut moved in a a square motion, so you're just basically telling the donut to move down this much and right this much and go back and go back. So that's what's happening there, and it's again very easy to read. And the third and final demo I have for you is, surprise, a donut again. So the only difference you can see is that we have a start button and a pause button. And it's straightforward. You just press start button and then the animation starts. You pause and it pauses. But this time it's a bit more complicated. So let me show you what happens. I click start. And then you pause, and then you can see here, you can see the progress of the animation. So I paused at 66%. That's why the donut is kind of slightly tilted. It's still in the middle of the animation. Once I press start again, it goes till the end, and it logs out done in the end. So this is much more complicated looking than the other demos. And you might think the code is also complicated, but actually it's the same length of code as you saw in the previous one. It's 22 lines of code. And basically, on line 1 and 2, you're just declaring variables. Progress log is basically the numbers that you saw increase from 0 to 100. And finish log is the done in the end that you saw. And yeah, the actual animation is happening right here from line 4 to line 15, which again is just one timeline and one add. I rotated 3,240 degrees, which is like the spinning action going on. And inside the timeline, you might notice this update property that you haven't seen before. It takes in the animation that's happening, and every time it receives an animation, it takes in the anime and increments the numbers. And just you add the percentage to the end. And what's happening here is the pause and play button you saw. So on click, you do animation.play, which is another method that you can use in AnimeJS. You're just telling the animation to play, and same for pause, you're telling the animation to pause. And the thing that I wanted to showcase the most is the third and final strength of this library, which is you can use callbacks. So as you can see here, it kind of tracks your scroll, and based on where you're at, it kind of logs out the number. So that's the anime.progress that you just saw on my demo. So yeah, that is happening right here. The promise. So animation.finished means when the animation is finished, then please execute the function in here. So what it's doing is pretty easy to understand, I guess. Once the animation is finished, you change the log into done, and you change the background color to yellow. So yeah, that's my demo for AnimeJS. I hope you enjoyed. So next I will talk to you about my likes and dislikes about this JavaScript library. So what I like about this JavaScript library is that the code is pretty simple, as you saw. It's just maybe 20 lines of code. And the property names are pretty intuitive, pretty easy to understand, like animation.finished, animation.progress. It does what it says, so it's very beginner friendly. What I dislike is very minor points. Documentation, I found it hard to navigate at times because there's not a search bar. If I wanted to look for something, I would have to look through everything. And the second point is there's not much examples out there. Pretty much right now, it's just the creator of this JavaScript library who's putting out examples out there. But these 2 points, I'm sure it will improve over time because this JavaScript library is really new. So yeah, I'm not worried about that. So next, let's talk about 3Ds. We're going to use ThreeJS. So can I see a show of hands again? How many people in this room know about ThreeJS? Okay, thank you. So for those of you who don't know about ThreeJS, there are 3 main things that you should know about. Of course, as I mentioned, it's a 3D JavaScript library. It has a default WebGL render, and it also provides a lot of renders, Canvas 2D, SVG, CSS 3D renders. Yeah, but let's just dive into the demo. So what I created for you today is this website. I created it in less than 2 days. It's built on top of Python. But yeah, for now it's very simple looking. It's just 3 buttons, and when you click on Cube, for example, it takes you to another page which has a crate spinning, which is amazing. And a car. You get to see a car. You can spin it, you can zoom in. If you zoom in even more, you get into the inside of the car. Pretty detailed, very nice. And lastly, the C. I have a 3D model loaded onto my web page, which is pretty awesome. Yeah. So let me take you through what you need to do to set up your ThreeJS settings. There are 3 main things that you need to do. So first, you need to set your scene. What is a scene? It is kind of like a dark room. It's like a space for you to place your objects. You need that. And secondly, you need to set up your camera, which is kind of like your eyes. You need those as well. And third, you need a render, which basically loads everything and logs everything onto your screen. So to see this in action, well, not in action, but in code, this is the code, in the entire code. It's like 35 line. And on line 1, you can see we're declaring global variables. We talked about the scene, the camera, the render, the cube we're going to talk about later. So yeah, let me take you through the settings. So first, we set up the scene here. It's just 1 line of code, pretty simple. For the camera, it's just from line 6 to line 12. I'm not going to go into the detail, but basically we're setting up the camera here. And lastly, we're going to be setting up the render, which is happening here. You're just calling a method and setting the size of the render and appending it to the web page. So if you complete coding until where I explained, you'll basically get something like this, which is a dark screen because you haven't loaded any object into it yet. So let's log a crate. What you saw in my demo, which is this one. How do we create this box? So how to do that, we create a box instance using this box geometry. What's happening here is that we're creating a 3 by 3 by 3 box, but if you just load this, it's going to be invisible because it doesn't have a surface. So we want to load the surface that we want the box to have. So on line 19, you see we're using a texture loader, and we're loading this window.crate, which is basically an image. And we're putting that into a variable texture. And we have a box and we have a texture, and then we need to mesh them together, which is happening right here. We're putting the geometry, the cube we made, and the material we made, and we're putting that into a cube, and that's the crate that you just saw. And by doing scene.add cube, we're adding this cube we created into the scene. So basically, yeah, that's what you need to do to make this crate. Yeah, I would like to talk about the car models and the C models that you just saw, but time-wise I'm not able to explain it. But if you want to, if you're curious, you can come up to me and we can talk about the code that I did for this one. But yeah, let me take you through my likes and dislikes about this JavaScript library. So what I like about it is that it's super lightweight. As you saw, we had a car model logged on to the screen. It looked really detailed, but it loaded super fast because the code is super lightweight. And there's lots of freedom when it comes to tweaking cameras and lighting, for example. There's a lot of room for things that you want to try out. But on the flip side, because it's so, it allows you a lot of freedom, it can get hard to use. It can be hard for you to get used to as a beginner. So that's pretty much what I have for you today. Thank you very much for coming to my Tech Talk. This is my LinkedIn account and my GitHub account. Yeah, so thank you very much.
Alright, so hello everybody. Thank you so much for coming here today. I'm so excited to talk to you all about React hooks and explore with you this new feature of React. But before I start, let me introduce myself. My name is Ryohei Watanabe. Before I was a developer, I was working in consulting, mostly at a small consumer goods startup where I was managing designers. My academic background is in political science, English literature, and economics. But nowadays I am focused very much on React and Node and building full stack applications. So React hooks, what are they? Now before React hooks were released in February of this year, the way to get state into your components was to call what is known as a class-based component. Your functional components in React were simply to take in props and to render JSX. Now, what React hooks allow you to do is have the same kind of stateful logic within functions. And I think this actually allows for a lot more reusability between components and actually a lot more cleaner code. But it's completely opt-in, and so if you have full stack applications or some sort of product right now that uses class-based components, you don't have to go back and refactor all of your code. In the future, if your team decides on it, it's an option as well. But it seems to me that this is the way the developer community is going. And so to get ahead of the curve, I think it's a good idea to learn about React hooks. And so you might be asking yourself, like, class-based components are fine for me. I love them. I know what lifecycle methods are. So why should I use or learn React hooks? I think at a high level, what hooks allow you to do is actually write much cleaner, much more readable code. So somewhere I read that most coders actually read 10 times more code than, spend more time reading code than writing code. And so readability is actually a very big issue and a very important thing to take care of. But also, I think because hooks are actually just functional components, you don't have a lot of the overhead that comes with class-based components. You don't have the lifecycle methods, you don't have the bindings, and you also don't have hidden inputs, hidden side effects. Also, so for hooks, they're going to encourage a decoupled logic, so you can share logic between components. And for all of you TDD folks out there, this is why functional components are so testable and the way to go in the future. And lastly, there's performance as well. The responsiveness of hooks and functional components give a much better experience for your users as opposed to class-based components. And so today, this is kind of what we'll be talking about. I'm going to begin with a useState, which is your basic building block of a functional hook. this is going to allow you to have stateful logic inside of your functional components. Next, I'm going to talk about use effect, which for those of you that come from a class-based components background, it's your lifecycle methods, your component did mount, and so on. And lastly, we're going to build off of this use state and use effect knowledge that we've gained and create our own custom hooks. And so let's get started. All right, use state. Use state just is the first time you can have state in your functional components. Now, the way to think about it is really this.state and this.setState before your functional component, and we're going to call that with use state. And so, what is the syntax for this? What does it look like in real life? So first, you're going to declare a functional component, and in the first line, you're going to call it use state. And you want to initialize use state with some sort of data type. It can be a string, such as React. It can be an object with multiple properties, or it can be a 0. In this case, we're going to use a number because we're going to create a count variable. And we're going to use, on the left-hand side here, we're going to declare const and use ES6 array destructuring syntax, because use state is always going to return an array with 2 elements. The first element is going to be where your state lives. And so whenever you want to access the current state within your JSX or within your functional component, you're just going to reference count. And so what happens when you want to change this, when you want to update it, like this.setState? What you're going to do is also declare within this destructured array a set count. Now you can name these variables whatever you want. Hopefully it's something descriptive. But by convention, we're going to call set plus something, the variable name that you created in the first element, just by convention. And so I kind of want to go through with you a simple kind of web page with 2 buttons and a div that renders the current state. And so the first set state here is going to increment by 1, and the second one is going to increment to 0, or back to 0. And what I want you to see on the right hand side here is that overall your functional components don't look too much different than what you've known. And so a lot of your knowledge that you've gained about functional components still stand. All that's different in this scenario is that you're just going to call use state right beneath function declaration. Another thing that I want you to see as well is, so I've highlighted all of the kind of stateful logic within this functional component in green. And so when we call on click, or when we click the button to increment by 1, you're going to call it a little differently than when you want to reset to 0. When you want to increment the count variable based on any previous state, you're going to call set count with a callback. And React will automatically offer you the previous state as the first argument. And so in this callback, we're going to return previous state plus 1. In the case that you want to hardcode or reset to 0 or some other kind of primitive type of data, you're just going to call set count with the number. And so if you do use objects with lots of properties as within your use state variable, what you're going to do is you're going to use this previous state callback within set count, and you're going to have to merge the next state and the previous state. Unlike this.setState, set count is not going to automatically merge those objects for you. And so I kind of want to go back here to kind of the tips here. The reason, so you want to keep your use state hook and the variables that you initiate it with and that you keep in there as minimal as possible. And so if you have a lot of states that you want to keep track of, you don't want to jam that all into one object like you would in a class-based component. You want to kind of separate them out into things that either go together or to primitive data types. If you can have just a series of use state calls, you want to keep them separate. And here's why. By keeping them separate, A, it's more readable. B, it's going to allow you to refactor and create separate functional components for each kind of logic. If you use objects, like I said, you're going to have to use that callback and automatically merge these objects. And also, the second thing you should keep in mind is that you can't have hooks within conditionals. I mean, it's just one of the rules of React that when they call, when it reads over your functional component, React needs a way to distinguish between the first use state call and the second and the third and the fourth. And the way it does that is by keeping track of the sequence. And so if you call use state or any other hook within a conditional, the sequence is going to get out of line and it's going to cause bugs. And now, so next, I kind of want to go through use effect. I mean, so you have state now in your functional component. What can you do with it? Like, what's going on here? Like, what do we do? We're going to actually have a use effect. And the way I kind of like to think about it is use effect is much like the traditional class-based lifecycle methods that you know, such as component did mount, component did update, and component will unmount. But now it's all combined into one hook called use effect. So what is the syntax for use effect? Use effect is going to take in a callback. And within this callback in the body right here, you're going to do all the logic that you would in component did mount or component did update. Usually what you'll see in here are like kind of API calls or adding event listeners. This is the only thing that's actually necessary about use effect. The other two things here are optional. So in the green here, we have a return callback. And what you're going to have in the return callback is all of the logic that you would put in component will unmount. And so if you have some open event listeners that are still in the DOM, then you want to take out those, remove the event listeners, or unsubscribe. And lastly, we have an array dependency. So the last argument for use effect here in orange is going to be an array. And within this array, you can put in props or state variables that this use effect will now watch over. This use effect is going to watch for changes in these variables, and a change will now cause make use effect like go through the logic in the body here. And so I kind of want to show you exactly what this looks like within my very sophisticated app here. And so here we have a kind of news articles. So we're gonna have three separate use state calls. One for the news, where we're gonna hold all of this data. Another for the subject on line 4 here, and another for search. So what the news, we're using the news to take the result of a Axios GET request and store that data somewhere. We're going to use subject, the green here, as a part of set subject, which is going to be the result of entering something into this search bar. So if we want to find out what Apple's been up to, when we click enter, what's going to happen is on submit, down here on line 18, 19, and 20, we're going to take in the search variable or the search state and send that as an ID to this API, to this Axios request. And as a result, the use effect is going to re-render everything. And so kind of what I want you to see here is actually how much cleaner this functional component is than the same functional or the same logic within a class-based component. And so here's what we have on the left-hand side is the kind of the same logic in a class-based component. When you're calling, when you're initializing state, you're going to call this.state with some data array. And then the same logic is going to be one line in a hook. We're going to call useState with data and have the same kind of functionality. We're also going to call fetchMyAPI here, and we're going to take that out of the component did mount and component did update as its own sole function. And on the right-hand side, we have the same thing. But instead of this.setState for a class-based component, well, we're going to call it setData with the result. And then you can see here the component did mount and component did update lifecycle methods. These are doing the same thing. They're both calling this.fetchMyAPI. The only difference is with component did update, you now have to avoid an infinite re-render or an infinite loop by creating this conditional. And what you're going to give component did update is an argument called previous props. And you're going to check if the previous props is the same as the props right now. All of this conditional is now implicit in use effect. you only have to write fetch my API once within the body of useEffect. UseEffect is going to watch over props.subject and only conditionally render when there's a change to props.subject. And so I kind of want to talk to you about the tips with useEffect. In the last argument of useEffect, you have three options. You can either put in a variable such as props.subject, and this will make a conditional render for useEffect. You can also have the option of not putting anything in there at all as your last argument, and in this case, it's going to run the body, such as this.fetchMyAPI or fetchMyAPI, will run on every single render. And lastly, you can also have an empty array, and in this case, useEffect will run the body on the first render and the last. So component did mount, and component will unmount. So taking these, the useEffect and the useState, I kind of want to go through custom hooks with you. Now, what are custom hooks? Custom hooks are just simply functional components with a kind of extracted logic that has access to other hooks. And so what the point is to actually be able to reuse components everywhere. And so I've added a simple clock to the same news component beforehand. As you can see here, we have a clock, and I've highlighted the kind of logic behind and the code behind this clock within this news component in green. And so we're going to call useState with time, and we're also going to set the time with this set interval. It's going to update every second, and then we're going to return a clear interval when we want to remove this set interval. And we've also added a red empty array here as the last argument to useEffect in order to call it once on mounting and then once before it dismounts. Now, what I want you to see here is it's not necessary to have this clock logic within this functional component. This can be somewhere else entirely. It doesn't have to live here. And the reason I guess it lives here is because we haven't used a custom hook yet. And so I kind of want to refactor this code with you all here today. On the left-hand side, we have the same code as in the previous slide, or in the example. But now we're going to take this useState call here and really just copy and paste it into a new functional component that we're going to call useTime. And then we're going to take out this kind of tick function that sets the time again with a new date. And we're going to bring it over to line 4 through 6 here. And then we're going to do the same thing with useEffect. And then, like any other function, you're now going to just return any kind of variable. And in this case, we're going to return timer because we want to reuse this variable. And now, what do you do next? All you have to do is call const timer is equal to useTime, this custom hook that you just made, and render it in a div. And now you have a timer or a clock that you can use anywhere. Now, I think this is kind of the power of hooks, and the reason why you would want to use this in the future is because you don't have to rewrite all this logic if it's decoupled in this way. You can reuse it and never have to write another line of code again if you wanted to. And so, as a summary, we went over today useState, useEffect, and useCustom. There are so many other custom hooks that you can get into that are like for performance optimization or for any other thing. I would really recommend going through the docs. They're really, really good. And so, I guess thank you for coming today. Thank you for sharing my love of React. And if you guys have any questions, here's my information. Please contact me or just ask questions now. That'd be fine as well. Thank you.
Yeah, hello, my name is Brittany. Today I'm going to be talking to you guys, as Nicholas said, about virtual reality in the medical world. Before I get started, I'll tell you a little bit about myself. I'm from the United States in Los Angeles, California. I received a bachelor's degree in public health 2 years ago, and since then I've been learning how to make my own full stack applications, programming primarily in Ruby and JavaScript this whole time. A little bit about my hobbies. I'm a long distance runner. I like to dance. Yeah, that's it. Okay. So Today I'm going to be covering how VR can be used to assist with mental health diagnoses, as well as in pain reduction, paying special attention to burn victims and amputees. I'm also going to be discussing how VR is being used to treat post-traumatic stress disorder, in addition to a few other less severe anxiety disorders. And then I'm going to wrap it up with a demo of a React 360 VR app, which I built that's designed to help you overcome some common phobias like a fear of driving, public speaking, and heights. Okay, so to begin, a quick introduction as to how VR can help with mental health diagnosis. Like, how is this even related? VR gives psychiatrists the ability to observe their patients in a wide range of virtual environments, and they're able to make observations about a patient's behaviors and physiological reactions to various stimuli. So this provides standardization, which also decreases the subjectivity of mental health diagnoses, which is a problem. And on the flip side of that, there's also some flexibility. So a VR environment can be customized and adjusted to suit an individual patient's needs. So for example, if an environment maybe is too triggering for a certain individual, that can be adjusted. There is that strength of flexibility there. So an example of this in the real world, this is actually an image from a virtual environment that was designed at the University of Cambridge as part of a study to help detect early stages of Alzheimer's. So this is a game. It's like a navigation game, and all the participants in this study are wearing a VR headset, and they have to follow these cones, and it ends up taking them in an L-shaped path. And so when they turn around, this is what they see. The cones are gone, and their task is to retrace their steps in that same L-shaped path. And poor performance in this task is indicative that maybe you have an early stage of Alzheimer's. And a little bit about this study. It was led by Dr. Dennis Chan at Cambridge's Department of Clinical Neurosciences. They're using an HTC Vive headset. And the study is actually still underway for another year and a half, just so that they can collect a larger sample size to, ensure the accuracy of their results. They have published some preliminary findings which are very promising, and they've discovered that this is actually more accurate at detecting early stages of Alzheimer's than the more traditional cognitive tests that are currently used, like figure recall, which would be like being seen a series of images and having to recall if you've seen one before. Like a symbol test would be something like having to solve a puzzle where there's corresponding symbols with numbers and having to decipher that. So those are the more traditional ways of detecting Alzheimer's in its early stages. But the findings of this study lead us to be optimistic about the potential of VR and playing a bigger role in diagnosing mental disorders as the gear becomes cheaper and easier to use. So this is another virtual environment that was developed in Germany at the University of Regensburg. And they're using this environment to test the suitability of VR for diagnosing social anxiety disorder. So this is a virtual waiting room. And in the study, they were comparing two different groups of people. People who scored low on a scale of social anxiety and people who scored high. And they're comparing the results to see, will this be consistent with their social anxiety? So each participant had a task where they entered this environment and they had to approach the clerk, make eye contact, and ask for a seat. And they would end up being rejected for their seat because there are none left. And so all the participants were asked to report their expected fear before beginning the task, and then after the task was over, they reported their actual fear experience. And throughout this study, they were actually tracking all of their eye movements. So that's where you see some interesting data. Maybe a limitation of this study is that these 3D models, I think, are a little scary regardless of whether you have social anxiety. But the findings are still significant. They do see a difference. So the dark gray is the highly anxious group, light gray is the lowly anxious group. So definitely a huge disparity in reported fear before and after. And so this is their eye movements. So you can see that the low anxious group was more likely to direct their eye contact at the face of the 3D model and less likely to direct their eye contact at the body or in the outside environment, which might, reflect how these people would interact with other individuals on a daily basis. And so they used another virtual environment that was just interacting with one person. This is like a virtual train. They had to also make eye contact. That was a part of the task. And they were asked to perform a basic calculation question. We'd ask them a simple arithmetic question, and they had to make eye contact and answer it. As you can expect, the relationship between the two groups' data in this environment is similar as the other one. So you see the consistent difference between expected and actually experienced fear. And then also, again, the highly anxious group is less likely to make eye contact with the face and more likely to direct their gaze at the body, the 3D model, and at the outside environment. This one was interesting in that both groups actually had a very high rate of directing their eye contact in the environment. So overall, they did conclude in this study that being able to track eye movements in VR is a very good and helpful indicator when diagnosing social anxiety disorder in the future. Okay, so now I'm going to move on and talk about how VR can be used to reduce your pain. So there is a huge psychological component of pain, as I'm sure some of you can imagine, and this is the aspect of pain that VR does have the potential to reduce. So this is accomplished by creating a distraction for your mind via a VR environment. And when you do that, you're subsequently able to direct less attention towards processing the neural signals that are coming from the pain receptors in your brain. And so it's important to note that VR, thus far at least, is being used as a complement rather than as a substitute for traditional pain medication. So this means that if an individual patient doesn't see any real benefit, no reduction in his pain from VR, they're really no worse off. So the risk here is very minimal, which is a big deal when it comes to other pain reduction methods. Again, on the flip side of that, if an individual is noted to respond particularly well to VR in reducing their pain, or if a specific demographic with a certain treatment in a VR room it is seen to be more successful, this can lead to a reduction in dependency on opioid medication. Okay, so on the bottom left, we see an image of a VR environment. It's actually a game, and it's called Snow World. And it was developed at the University of Washington, designed specifically for burn victims to play during their wound treatments. So a little bit of background about these wound treatments. Burn victims have to have these treatments every single day, and they're very excruciating because it actually involves the stretching of their skin. And because it does happen every day, they can't really receive any other stronger pain medications because of that. So they can't go under, for example. So this is really important. And so here's an image of the game of Snow World. It basically just involves throwing snowballs at the snowmen and at the penguins before they can throw them at you. And it's also playing a Paul Simon song in the background. It's I don't know, I think just the researcher likes Paul Simon. And the Arctic setting was a very deliberate decision. So they did use this Arctic environment to provide a mental juxtaposition to fire. So to distract their mind and have them not only engage in playing a game and in listening to some happy music, but also to be thinking about ice as they're receiving treatments for their burn wounds. So about this study, it was led by Dr. G. Hoffman at the Virtual Reality and Analgesia Research Center, which is cool that there is such a thing at the University of Washington. And their patients actually reported a 35 to 50% reduction in procedural pain. And to make sure to account for any subjectivity in the patient reportings, they spent 2 years developing a special VR headset which could be worn inside of an MRI. And so they did the same study 2 years later, having the patients actually go inside an fMRI, where they're able to collect data from brain scans and prove that there is indeed a reduction in pain-related brain activity. So here's a photo of one of the patients receiving her wound treatment while playing the game. You'll notice here there's actually a robotic arm holding up the headset to her face. This is in case it's a sensitive skin area for one of the patients to avoid putting any pressure on the skin on their face, how a VR headset would. And so yeah, so she's playing the game by clicking the mouse and is able to rotate there with her finger. Okay, so next I'm going to discuss how VR is also being used to reduce the pain experienced by amputees. But before I begin, let me experience this phenomenon called phantom limb. So phantom limb, which is also referred to as PL, is experienced by well over half of all amputees. So it's like fairly common, and it is the sensation that a missing limb is still present. So unfortunately, more often than not, the sensation is very painful, and this is called phantom limb pain, PLP. It manifests in all different types of forms, but it's often described as burning, or like a squeezing, shooting, stabbing sensation, cramping. Sounds pretty terrible. So there's actually no common consensus about what causes PLP, phantom limb pain, PLP. But there has been success in treating it, and that is usually accomplished via visual treatments, the creation of visual illusions, which can actually trick our brain into evoking some type of kinesthetic sensation in a missing limb. So this is a mirror box. This was developed in the 1990s to treat phantom limb pain. So in this example, this would maybe be a diagram of somebody with an amputated right arm or right hand. And if they're experiencing pain, they can use this mirror here to create this illusion that the limb is still there. And that is not only able to help reduce the pain, but can also help train your brain that it is missing. So here's an example of some like a pseudo mirror box using for someone with an amputated leg. Obviously, this illusion isn't very realistic. It is not really fooling anybody. So yeah, it is overall very successful, but of course not everyone sees improvement from this type of mirroring treatment. But you can create a much more immersive effect with VR, and that is being developed. And the really cool thing about simulating something like this with VR is that you can actually isolate the movement of your limbs with the assistance of other more advanced technology that I'll talk about soon, instead of just mirroring the existing limb. Okay, so this is a study that was conducted at the University of Pennsylvania's medical school. So they're using an Oculus Rift DK2 headset, and they actually have inertial measurement units here mounted onto an Arduino board. IMU's inertial measurement units are just like small electronic devices. They measure and can report a body's specific movement force and also the angular rate. And so we have 3 different VR games here that they developed for this study. One of them is playing chess, in which you can actually pick things up. And the second one is a game that involves walking and running through an environment. And the third one is typing at a computer, navigating a web browser. And so yeah, they're using Arduino microcontrollers to send readings from the IMUs to a computer, and then Unity scripts are filtering those readings. So yeah, I mean, all these games are pretty simple, but it's amazing. So in this picture, we have somebody with an amputated left leg, and through the IMU's detections, maybe here in their upper thigh, they're able to create this illusion that like mirrors the readings from the IMUs, and they could walk and run through this environment, which has been tremendous in helping them reduce their phantom limb pain. So unfortunately, this study only had 2 participants to report data from. So the dark circles is one patient, gray squares is another one. And so they had 4 different hour-long sessions, and they reported their pain at the beginning of a session and also at the end of the hour. So you can see a really dramatic decrease in pain, almost always completely to 0 at the end of the hour of playing these games. And also what's fantastic is there's an overall decrease in the initial pain as well. Okay, so next I'm going to talk about how VR is being used to treat patients with PTSD. Before I get into that, I'll just provide a brief introduction to this illness for anyone who isn't familiar with it. So PTSD stands for post-traumatic stress disorder. It is caused by experiencing or witnessing something very terrifying, and some common symptoms of it involve flashbacks of that traumatic event, intense physiological and emotional reactions to anything that might resemble that event, avoidance behavior, again, to anything that might resemble that event or trigger memories of that event, emotional numbing, and irritability. And it is most often seen in war veterans, survivors of a terrorist attack, and victims of sexual assault. So the most effective way to treat PTSD is called prolonged exposure therapy. So this was also developed at UPenn by a famous psychologist, Dr. Edna Foa. And it involves exposing a patient very gradually to the stimuli that do activate their strong responses. And so via this gradual exposure, a patient is actually able to learn how to confront that trauma and learn how to deal with and manage those undesired responses. And so once they're able to do this, then those symptoms from the previous slide are reduced. And so maybe you're wondering what all of this has to do with VR. Well, a large part of prolonged exposure therapy is dependent upon a patient's ability to imagine. It's really dependent on their imagination. There's a lot of exercises that involve reliving a certain memory and reliving these traumatic events, which is a lot to ask for. It's a lot to ask of a PTSD patients to relive these types of things, especially when one of the main symptoms is avoidance behavior, and also PTSD is highly correlated with depression. And obviously, it's impossible for a psychologist to standardize or control the patient's imagination. So this is where VR can step in and really revolutionize the way that this exposure is given. And there are people working on that already. So this is BraveMind. This is a VR game that was designed specifically to treat the PTSD experienced by veterans in the United States with combat-related PTSD. And yeah, this develops at the University of Southern California's Institute of Creative Technologies by Dr. Skip Rizzo. And it works pretty much the same way as more conventional prolonged exposure therapy, in that the exposure to the stimuli is very gradual, right? They don't just throw someone into like a combat scene. So for example, this would be an example of a first introductory steps. This is just a scene that is designed, this is from BraveMind, and it's designed to look like a street in either Afghanistan or Iraq, which are the countries that the patients did experience combat. So yeah, there's nothing really intense or violent going on here. And once a patient is able to stop having strong emotional, physiological reactions to a scene like this, they would then move on gradually to scenes of greater intensity. And they're always under clinical care, by the way. This is something that, it's not a video game that you can play at home. So yeah, so maybe you'd move on to something like this, where you see a soldier, a gun, but again, really no violence happening. and then something like this, and it goes on and begins to resemble something that looks like Call of Duty a bit. But as I mentioned, this is designed specifically for its medical purpose, and there's no way to access this game unless you are a patient of Dr. Rizzo or you know him really well. But so yeah, sorry to the gamers. And yeah, this philosophy of VR exposure therapy can also be used to treat much less severe anxiety disorders. So this is my disclaimer slide. That my next slide has a picture of a big virtual spider. So I'll talk about it now in case that bothers anybody. An example of a less severe anxiety disorder would be arachnophobia, or the intense fear of spiders. And so there are actually a number of VR games, some of them you can just play online, that are designed to gradually expose you to virtual spiders and help you to overcome this fear. And it was actually the lab at the University of Washington, the same lab that designed Snow World for burn victims, that also created a really cool study that involved a spider being really small and far away in a kitchen, and then suddenly by the end it's like really big in front of your face, and they even had like a fake spider model that you could reach out and touch to feel like you're touching the real thing. And there were some people after that study, and mind you, these were all people that had very intense arachnophobia, like a very strong, irrational fear of spiders. And some of them were even able to touch a real tarantula after. So I'm going to change the slide now, so close your eyes if you want. So here's a picture of someone reaching out. They would be looking at something like this. And there's a few versions of stuff like this. Here's a more cute one. It was actually a game called Bitsy. And you play a game with this spider, and as you progress through the game, the 3D model becomes more and more realistic looking. So it starts off as this very cute, cartoonish, friendly looking spider, and by the end of the game, when you're on level of 10 or 20 or so, it's like a very realistic looking tarantula in front of you. And this game is actually developed by Samsung in partner with a Swedish startup called Immersive. And this is actually the inspiration behind my application. There's no spiders, but so I do design an app using React 360, which is built right on top of React. It's very similar to React Native, if you're familiar with that. And it's managed by Facebook and Oculus. And so I create these illusions via 360-degree videos. I actually rented this camera for a few days and went around Shibuya capturing some footage. So I captured 360 video of driving through Shibuya, riding the giant Ferris wheel in Odaiba inside the 360 glass gondolas that they have. And I also filmed a video over there in this room of having a bunch of people staring at you, how you're doing to me right now. I'll go ahead and show you that now. So this is the screen that you see, and actually the way that you select these things. So right here, height, drive, public speaking, these are all buttons, but you see I can't actually click them with my mouse. These are gaze buttons, and the way that you select these things are by hovering over them with your gaze, and there's a countdown of 2,000 milliseconds, and when that countdown finishes, while the gaze is fixed over the button, you can enter. So the gaze is used with a raycaster, which is centered in the middle of the screen. So if we bring this over, so you can see that white dot here, right? So if we center this over something, let's go into public speaking, we see a countdown. And now, this is Yan and Frank. Also, I don't recommend using this camera, the same camera that I used to build your own VR applications. Spend some more money and you'll have a far more superior product. But you can do a full 360 turn. Okay, takes a while. That's the whiteboard. And if we want to go back to the main menu, we would just hover over the home button, the same as before. We have to get it in the middle. Great, so yeah, we can go into heights. This is the Ferris wheel. It is slowly moving. You can see the floor is glass as well. Well, that's the tripod and my feet. Because, yeah, I'm in this video. And yeah. And we can go back. And the last one is driving. So you can overcome your fear of making a right turn in Tokyo, which I am afraid of. It's scary for people that come from a country, especially that drive on the left side of the road. But yeah, that's my app. Each video is about 2 minutes long, and they will loop forever. And yeah, these are the sources from all the research studies that I presented to you today. So if you're interested in learning more about this, when this is uploaded on YouTube, you can refer to this. And thank you. Here's the demo QR code. Thank you for listening. That's all.
So thank you, Brittany, and thank you so much. So this is the end of our last presentation. So thank you so much for coming out. So we have about 30 minutes from now. So for the next 30 minutes, I want to provide some time for networking. So please, for people who came out tonight, get to know our presenters. They all have very interesting backgrounds. So if you want to ask questions about the presentation or why they're here, please go ahead and do that. And I hope you can also get to know the people who are here in the audience too. So thank you again, and thanks again to Brittany.